how empty space became the most powerful thing in the universe. For most of history, emptiness was ignored. Nothing felt unimportant. Absence seemed powerless. But space was never truly empty. To understand how empty space became powerful, we must rethink nothingness. Early physics treated space as a passive stage. Events happened inside it. Matter moved through it. Space itself did nothing. That assumption shaped intuition for centuries. Then measurements began to disagree. Light behaved strangely in a vacuum. Energy appeared where nothing should exist. Particles emerged, then vanished. The void refused to stay quiet. In the 20th century, experiments forced a revelation. Empty space was not empty. It was active, restless, filled with invisible structure. Vacuum became a physical entity. At quantum scales, space seethed with activity. Fields fluctuated constantly. Pairs of particles flickered into existence briefly. They borrowed energy, then returned it. Nothingness behaved like a storm. At first, this sounded like mathematical trickery, a bookkeeping illusion, but experiments proved otherwise. These fluctuations had measurable effects. They pushed, pulled, and altered reality. Even when stripped of matter, space retained energy. Not motion, not particles, but potential. A baseline hung beneath existence. The vacuum was not zero. It was full of tension. This changed everything. If space contained energy, it could influence matter. It could curve. It could expand. It could dominate the universe itself. Emptiness was no longer passive. It was a participant. As theory advanced, the implications grew unsettling. If empty space had energy everywhere, then its influence would accumulate, quietly, relentlessly, across the cosmos. Physicists realized they had underestimated the void. What they once ignored might control fate, because when nothing pushes back, everything else must respond. The power of empty space revealed itself through subtle effects. One of the strangest was the Casimir force. Place two metal plates extremely close together. The vacuum between them behaves differently. A pressure appears. The plates are pushed together by nothing at all. This force comes from quantum fluctuations. Space allows certain vibrations. When boundaries restrict them, imbalance forms. That imbalance produces measurable force. Nothing pushes something. At first, this seemed like a curiosity, a laboratory trick, but it hinted at something deeper. If empty space can push metal plates, it can influence much larger systems. Scale changes everything. Then cosmology delivered a shock. The universe was not just expanding, it was accelerating. Galaxies were being driven apart faster over time. Something was pushing space itself outward. This force did not come from matter. It did not come from radiation. It came from space. Empty space exerted pressure. A repulsive energy filled the cosmos. Physicists called it dark energy. Dark energy does not cluster. It does not form objects. It acts everywhere equally. The more space exists, the more energy appears. Expansion feeds itself. This makes empty space dominant. As the universe grows, matter thins. But vacuum energy remains constant per volume. Eventually, emptiness outweighs everything. Nothing wins by doing nothing. This discovery overturned expectations. Gravity was supposed to slow expansion. Instead, space pushed back. The void was not collapsing. It was accelerating reality apart. This raised terrifying questions. If empty space keeps expanding, will galaxies disappear beyond reach? Will the night sky go dark? Will isolation become inevitable? The universe's future now depends on nothing. Not stars, not matter, but the behavior of empty space itself. And physics still does not fully understand why it exists. As scientists followed this trail, the conflict sharpened. Empty space was doing too much. Its energy should have been enormous. Yet observations showed a value absurdly small. Physics predicted one number. Reality delivered another. This mismatch was not minor. It was the worst prediction in scientific history. Off by more than 100 orders of magnitude. No theory could explain the difference. The most powerful equations ever written failed completely. This created a crisis. If vacuum energy exists, why is it so weak? If it is weak, why does it dominate now? Why not earlier? Why not later? Why does emptiness wait, then take over? Some proposed hidden cancellations, forces that perfectly balance vacuum energy. Others suggested new particles, new symmetries, new dimensions folded beyond perception. None solved the problem cleanly. The universe seemed finely tuned, balanced on a razor's edge. If vacuum energy were slightly stronger, galaxies would never form, stars would never ignite, life would never appear. If it were slightly weaker, gravity would dominate forever. Expansion would slow, collapse might follow. The universe we see exists in a narrow window, suspiciously narrow. This led to uncomfortable ideas. Perhaps many universes exist, each with different vacuum energies. Most are lifeless. We observe this one because we can, not because it is special, but because it allows observers. This explanation felt unsatisfying. It replaced understanding with selection. Physics became statistics. Meaning became accidental. Many resisted this conclusion, yet observations offered no alternative. Empty space behaved as if tuned, as if waiting, as if patience itself were a force. The universe expanded gently for billions of years. Then acceleration quietly took over. This timing mattered. It allowed structure to form first. Galaxies, stars, planets. Then isolation began. Empty space started winning only after complexity emerged. This made the conflict existential. The force shaping the universe's fate is not fire or gravity. It is absence, and it is growing stronger as everything else fades. The climax arrives quietly, without explosions or collapse. Empty space does not conquer by force. It wins by patience, by existing everywhere all the time. As the universe expands, matter spreads thin, stars burn out, galaxies drift apart. But empty space does not dilute. Its energy remains constant. Volume increases, influence grows. Nothing becomes dominant by waiting. This reframes the fate of everything. The universe is not ruled by what exists. It is ruled by what remains when everything else fades. Emptiness sets the long-term direction, not through violence, but persistence. In the distant future, galaxies will slip beyond visibility. The night sky will empty, not because stars died, but because space grew between them. Isolation will replace connection. Silence will replace light. This does not mean destruction. It means separation. Structures will still exist locally, but the universe will fracture into unreachable islands, each region alone with its own fading history. Understanding this changes how we see nothingness. Empty space is not absence. It is a property, a condition with consequences. It shapes expansion, destiny, and limits. The void is active. Modern physics still struggles to explain why. Why vacuum energy exists at all. Why its value is so small. Why it waited so long to dominate. These questions remain open. The most powerful force is still unexplained, yet its impact is undeniable. Every future calculation must include it. Every cosmic prediction bends around it. The universe's story is written by what we cannot see, by what appears to be nothing. This lesson echoes beyond cosmology. What seems insignificant can decide outcomes. What feels empty can hold power. Absence can shape reality as strongly as presence. Physics reminds us not to trust intuition. Empty space does not announce itself. It expands quietly, patiently, relentlessly, and in doing so, it decides how everything ends. Subscribe to join the journey. How